So I just wanted to make this real quick to kind of show you what changes I made to your model, so you're not confused about kind of so you're not looking at like what the hell did he do, and just you know I don't want you to be confused about what I did and why I did it. So I just want to make sure that we're on the same page. So when you go to normal map stuff, you're clear on what changes I made and why I made them. So one thing that I really wanted to work in this edge here, right? So if you look at the model and you look at the reference image, in order to build that in, it's definitely a little bit higher. It would have been worked up probably somewhere around here, which would have altered a lot of the geometry, because if I made a straight line from this point all the way to the front, it would have terminated right around here, and that clearly wouldn't make any sense on this model car. So I kind of had to adjust the whole thing based on that. So what I did, I made the whole thing a little bit lower. Luckily, I was left with enough. Obviously, you know, if I were trying to make it like the model, you can see that the spatial relationships here are quite a bit different. Everything is just kind of out of proportion a little bit, but it's close enough that it makes sense. I just wanted to keep to the original model a little bit more true to life, I think, or the original image a little bit more true to life than kind of what we have. But working with what we have, I mean, it's not to say that this model was bad or anything like that. It was just I personally kind of envisioned it just almost an exact replica, low poly version of that car. So in order to kind of stay a little bit more true to life to that, what I did was make some small adjustments. It's still not a perfect replica of the car, but with as many, excuse me, with as little adjustment as possible, I made some notable, I guess, changes. So I guess first, since we're looking at it, the trunk, I just straight lined the trunk instead of having that curve at the end there, because that model of Nissan doesn't really have that curve built into it. So I just kind of made it straight across there, and same with the rear end profile. The rear quarter profile actually doesn't move in so much. If you look at the model, it actually stays pretty straight. It does have a bit of a curvature, which we kind of still maintained a little bit of, but I think in the low poly version here, we kind of went a little too far in on the rear end there. So I just kind of extended that out just a little bit. So on the low poly version, to match it up, you're just gonna have to bring this out just a little bit, and as well as this here, this top end, this sloping piece. If you can see kind of the model that we're working with, I wanted to avoid bringing this out as far back as possible, as far back as this is. But in order to do that, I would have had to change a little bit more with your geometry, and I really didn't want to do that. So, yeah. With I built in this front slope here for the profile, because obviously when you're I mean, we could have built this into the normal map here and actually just ignore this, because I'll just be splitting this down the middle and replicating it. For this right here, I just built that in because when you're looking at it from the side, those sharp corners are really going to be really obvious, and it's going to look kind of gritty. With the back, it's not really so bad, because with the back, I mean, it already does kind of have that sharp corner, so I didn't worry about that one as much. But with the hood, definitely, I wanted to build in that little bit of an angle there. It doesn't affect the UVs at all, really. So if you look at the UVs, it worked that in just fine with no problems. And since it is less than 90 degrees, or more than 90, excuse me, yeah, less than 90 degree angle, it kept it just fine, and Blender should take it just fine. It should keep that as all one piece. Yeah, that. Speaking of which, for Blender, so with normal mapping, I know you don't have a whole lot of experience for normal mapping, but with normal mapping, basically every time you create a surface that is more than 90 degrees, or is 90 degrees and higher. Actually, it's a little lower than that. I would say anything that's about 70 degrees and higher of an angle. You want those pieces of geometry to be two separate pieces of geometry. So if we separated this out, I'll show you right now how this is. When you create something in Blender automatically separates two pieces of geometry that are more than 90 degrees after you have UV mapped it. So when you declare this an island, right? It actually goes through and says, "Oh, this is an island. Well, this is a separate piece of geometry also then." That effectively doubles your vertex count, because now instead of having two pieces or two vertices or one vertex right here, you now have two vertices. That's both a good thing and a bad thing. For gaming, it's actually perfect. However, when you're working in a workflow and you're in the middle of a workflow and you're not quite done with a final, like this isn't your final piece, you still need to build a high poly version of this. It's a huge pain in the ass, because if you've laid out UVs, you've essentially taken one piece of geometry, which I know you probably created this, and this all from one piece of geometry, and probably this as well. I know you created those from one piece of geometry in Blender. But when you hand it off and it's not done being modeled, the OBJ comes in as separate pieces. So as soon as I go to do anything with this model, I have to sew everything back together, remerge all the vertices, and create a single model again. Even with little stuff like this, it actually took your single piece here and separated it out, because they are separate on the UV map, right? Which is actually, like I say, great for the final product, bad for the middle of the workflow. It's just a bad idea. So that's why that happens. And actually, like I say, anything that's above 90 degree, in order to be normal mapped without a huge gashing seam down the center and without all kinds of artifacts, it's actually great. It's part of the workflow to actually separate these out into two different models. That's perfectly fine. But you generally want to stay away from doing that when you're, or I mean, honestly, you can just create a hard edge. You don't actually have to separate it out. But that's Blender's kind of way of dealing with it, that's fine. It's not a big deal, because the game engine, even though out of Maya it may actually look like one piece, and I create a hard edge, like basically what you have to do in Maya is, say this were a 90 degree edge, instead of making it two separate pieces, all I need to do in Maya is just harden edge, and then anything with a hard edge will be treated as a separate piece of geometry in Maya. It's really difficult to explain, but when I export it to any game engine, it's going to treat it as two separate UVs. Like this, even though right now in engine or in a 3D modeling program, this is just one single vertex, right, or vertex, right? If that's a hard edge and it's more than 90 degrees and it's its own separate island, like these two pieces are two separate islands, right? Like if this flat piece and this flat piece, which would theoretically be 90 degrees, if those are two separate pieces in the UVs, then in game it's going to make this one vertex into two vertices, because that's just the way that it goes. And that's actually that's a lot of why when somebody asks you what your vertice count is, or what your, it's actually most times when people are talking about um, like efficiency and modeling for game engines, it's less important what your quads are, or what your triangle count is, and actually a little bit more often than not, more important what your vertex count is, because of the way that game engines kind of tend to separate those out. So that, I just wanted to touch on that real quick since we were on that topic, and also, actually, give me a second. I have to let my dog out, so I'll be right. Okay, so yeah, that's it. Oh yeah. So here is, like I said, since we're on the normal mapping kind of topic here, what I'll do is you have this, which this is your deal here with the high poly parts. So I'm going to do a smooth mesh preview here real quick. Just kind of Maya's way of just previewing what it would look like if you applied the smooth algorithm. So real fast, someday hopefully it finishes here. Okay. So your grill here. Let's unsmooth these actually. Your grill is actually, I know you made this with the intention of normal mapping it, but it's not going to turn out the way you think it is, and I'm going to show you why. So let's take this real quick, do a quick combine, and so I know you made this kind of with the intention of just creating a normal map. What I would assume would be a flat plane where you would just project this geometry onto that flat plane. That's both a good idea and a bad idea. Now, there's two ways of doing this. The way that I think I would probably prefer it would be to create a flat two pieces of geometry here. One with an alpha map that has these slats, which just show the bars, which will be normal mapped, and then a kind of flat plane in the back here that would just be black, right? So it would just be a single, like two planes, one plane on the top here and one plane in the back, right? And I'm not sure how you were planning on doing this, but regardless of how you were planning on trying to do this, the geometry as you have it right now isn't going to normal map like you would expect. So now, if you look at this bar right here, this is essentially how Maya is going to see, or any normal mapping, X normal, Blender, however you plan on normal mapping it. Presumably, I guess you're going to use Substance Painter. This is exactly how whatever program you're gonna use is going to look at this piece of geometry, and you can see the problem. I think I cannot determine, or the human eye cannot determine, or nothing can determine what the difference between, what the height difference is between this surface here, this surface here, or this surface here. The only differentiation of surfaces we have is kind of this little area here, this curvature on the sides here, this bevel on the corners. So the problem here is that what you need to do is I'm going to show you, I made kind of a similar piece up here. So if you take this, bring it up, and look at it. What I have is a piece of geometry that extends out at the bottom, right? So that when I'm looking at it straight on, I have multiple surfaces to reflect rays off of. And those multiple surfaces have a varying depth from here to here, right? So when I look at it from this angle, this flat, whenever I make this normal map, when I look at that flat plane, the normal map that's generated is going to show me the difference between this height and this height, depending on which side of the thing I'm looking at here. And it's going to be obvious that I'm looking at it, looking at something that goes into space. It goes down into the Z plane, right? So like I say, presumably, and real quick, we'll just do a really simple. We don't want that to be the search envelope. Hold on. So real quick, I'll go over kind of cages, because I know we talked about cages before, and why it's not always as simple as creating a cage out of a piece of complex geometry and then just transferring maps. Normal mapping is kind of a it's a learned art form filled with frustration. If you're going to go through it the hard way and kind of like the long way, it can be a real pain in the ass, and it can be a long process, kind of learning from your mistakes, when you could just do things kind of conventionally, I guess you would call it. So basically, we'll make a flat plane real quick here, and move it into here, which is presumably what we would do if we were trying to build a normal map out of this grill. Right? We would separate. We would have kind of a separate piece just for this grill, because honestly, this is going to be the only piece that's going to have any kind of transparency on it. And with UE4, it's not a big deal to just build in some transparency. We're going to have some, anyways, kind of a limited transparency for the windows. So we're going to have an alpha mask with this texture. Not a big deal, but say this is what we would do here. Well, actually, let's just bring this all the way over. Right. So now we've got two pieces of geometry. We got this one, and we got this one. Well, let's bring up the transmap. Our target mesh is going to be, actually let's clear all. Add selected, target mesh, and the source mesh is going to be this one here. Right? And just for demonstration purposes, I'm just going to show you what the envelope is going to look like here. Oh, what is wrong with you, Maya? Hold on a second. Let's try this again. Both. Oh, actually, I want to see both, yeah. And, oh, maybe I can't. Maybe I can't see that in 2015. Anyways, what would happen? All that's going to happen is a piece of geometry is going to be shot out with the envelope, right? There's a very specific envelope is also substituted by the word cage, right? That's exactly what it is. It's just creating a cage. It's going to shoot out a cage based on this one, on your search envelope, your percentage, however far you want it, and how much geometry you want to catch, right? But the measurements of that cage are very exact. You're not going to, you can't be like, oh, well, on this piece right here, I just want to bring this one out just a little bit, right? And then just kind of make that like that, and then be like, oh wait, this one I can probably no. Once you touch one of those vertices, once you touch one of those, once you alter the edge flow of that model so that it's different from this in any way, shape, or form, you effectively ruin the cage, and you have to start from scratch. Like you cannot, you have to. It's very specific. That is a normal generated extrusion, right? So the extrusion has to be, it all has to be proportional to the model in which you're developing the cage, in which you're developing the cage from. So you can't, you can kind of scale it in various ways as long as it's proportional and as long as you're scaling in in normal space, and not in world space or object space. So it's very specific on how you can kind of alter those cages. So just so you understand, that's what we're working with here. Now what that cage will do obviously is shoot rays from this to this, right? That's all it does. Shoots rays in a very linear kind of form. Just shoots thousands and thousands of little rays from this piece of geometry to that piece of geometry. Now, it doesn't in a way that's very, like I say, linear. It's not. It doesn't look for two pieces of geometry. It doesn't say like, oh, this surface is different from this surface. It's very like it perceives it exactly like your eye would perceive it, right? Like I can't tell how high this is off of this. There's just no way of doing it without other lighting. So we're using very neutral lighting in the normal process where it's just not it's not possible in a ray base and a ray traced environment to find out or to represent it, I guess is probably the better word, without building in some kind of flange at the bottom there, right, to show those two different surfaces. So exactly like I just did here. Let's get rid of that. Let's bring that up. When that is traced down, you're actually going to see there's going to be two different sides to this, right? There's going to be this thickness side, right? Because presumably you're never going to be looking at it straight on. So on the normal map, the way that normal maps will work is when I'm viewing it at this angle, this side starts to disappear a little bit, and this side gets accentuated, gets darker, right? And the opposite way, and the opposite would apply for the other side, because I've built in that I've kind of tricked the camera into viewing it as a piece of geometry that has a slope degradation from here to the base. You see how that works? So that's pretty much it. So just when you're building, whenever you're building something that you have two different surfaces in mind for a normal map, just keep that in mind and build your geometry to kind of trick the camera, I guess is what we would call it. And that's pretty much it. I just wanted to touch on that real quick. That's pretty much it. We're going to have to build some extra geometry, I think, and build them into the UVs. I'm not sure how much room the UVs have. Let me see here. I think we got some room. Honestly, we're going to have to build the undercarriage, too, a little bit. Just to... yeah, we're going to have to build a small undercarriage. I don't know if you want to do that and kind of transfer the normal maps or whatever, but it doesn't have to be very highly detailed. We can kind of grunge it up and make it look pretty dirty without the need of a very high detailed normal map. But that's pretty much it. I just wanted to go over that with you, and before I handed your model back to you. All right. Let me know if you have any questions.